I am Dr. Chituri, Associate Professor of Physics, Institute of Aeronautical Institute. Today, I am going to tell about the origin of magnetic moment. So, in this session, we are going to see and cover the topics introduction part of how the magnetic moment is originating, and then in that magnetic moment due to orbital motion, magnetic moment due to spin motion, and then magnetic moment due to nuclear spin, and what about the Bohr magneton. Also discussing about the Bohr magneton. Then we see that what are the references have been studied for this topic. So in this introduction, as we know that materials are made up of atoms. All the materials, whatever the material we can take, so all the materials are made up of atoms. So these atoms consist of a nucleus surrounding which electrons are revolving in their orbits. As we know that nucleus is at the center, so nucleons are inside the nucleus. So around this nucleus there will be electrons revolving around the different orbits. Okay, so atoms consist of nucleus surrounding, electrons are revolving in their orbits. So these orbital motions of electron establish a magnetic field, and hence we get orbital magnetic moment of electrons. So when the electrons are revolving around the orbits around in their particular path of in the way of orbits, okay. So when the electrons revolving around the nucleus in orbital motion, they establish some magnetic field. So that orbital magnetic moment will be there because of the orbital motion of electrons in their orbits. So while revolving around the nucleus, the electron spin about their own axis. So along with the orbital motion, okay, so the electrons spin about their own axis. They spin about their own axis. So which results in a magnetic field. So and we get a spin magnetic moment of electrons. So while revolving, so electron that is revolving around the nucleus, the electron spin about their own axis, so that it gives magnetic field, so that we get a spin magnetic moment of electrons. The nucleons in the nucleus also spins. The nucleons in the nucleus also spins, resulting magnetic field, and we get the spin magnetic moment of nucleus. So there are three types of magnetic moments. One is about the orbital motion of the electrons in the orbits, revolving around the orbits. So then the second one is when the electrons are revolving around the nucleus in their orbits, they spin about their own axis, so that we get a magnetic field. So that is called spin magnetic moment of electrons. Then coming to the nucleons in the nucleus, they also spin. They also in the spin motion, so that we get magnetic field, and that is called spin magnetic moment of nucleus. So in atoms, the permanent magnetic moments arises due to three types of motions. So permanent magnetic moment arises in atoms. The permanent magnetic moment arises due to three types of motions. One is the orbital motion of electrons, another one is spin motion of electrons, then the last one is because of the spin of nucleus. So these three types of magnetic moments are arised in the atom. So let's see one by one the magnetic moments. So here, magnetic moment due to orbital motion of electrons. So magnetic moment due to orbital motion of electrons. So which is denoted with mu suffix L, mu L. So let's consider an electron having mass small m, and charge of the electron is E, and this electron is revolving around the nucleus, which is in circular orbit with a radius of r, which is in anti-clockwise direction. Suppose we are taking an electron, so this mass of the electron is so this is an electron. So mass of the electron is mass of the electron is m, and the charge is E. And this electron is revolving around the nucleus. So here is the nucleus. So this electron is revolving around the nucleus in circular orbit. Which is of r distance. That is circular orbit of radius r, and the direction of the motion is anti-clockwise direction. So this m mass electron with E charge is revolving around the nucleus in circular orbit anti-clockwise direction. So let V be the linear velocity. So linear velocity is V. Linear velocity, and omega be the omega in this direction. Omega be the in this direction we have omega, that is angular velocity of an electron. So then the linear velocity of the revolving electron is equals to omega by 2 pi. So the linear frequency of the revolving electron is equal to omega by 2 pi. So when coming to the time period, so time period is equals to 1 by frequency. So that the time period of revolutions is equals to 1 by omega by 2 pi. So that 2 pi by omega. So the time period of revolutions is equals to 2 pi by omega. So the revolving electron in circular orbit establishes a current I. When the electron is revolving around the circular orbit, then it establishes current. So the current I is equals to charge by time period. Current I is equals to charge by time period. As we know that charge of the electron is E, and time period is 2 pi by omega. Time period is 2 pi by omega. So that when writing this, I is equals to charge by time period, it is equal to E by time period is 2 pi by omega. So E into omega by 2 pi, we have E omega 2 pi. So current, the established current due to revolving of electron in circular orbit, I is equals to E omega by 2 pi. So the current I establishes a magnetic field around the circular orbit so that the upper surface acts as a south pole and the lower surface acts as a north pole. So in this figure, you can clearly understand that this figure belongs to orbital magnetic moment of electrons. This figure belongs to orbital magnetic moment of electrons. Here, at the place of O, there is a nucleus, and here the electron is. So this electron is revolving in circular orbit, revolving in circular orbit. So the direction of the electron motion is in anti-clockwise direction. Anti-clockwise direction. And the distance from nucleus to, that is radius of the orbiter that electron is revolving is r. And when taking a linear velocity, so linear velocity is v. This is linear velocity. Linear velocity. And the mass of the electron is m. Charge of the electron is e. So when the electron is revolving in the circular orbit, then it produces current. So it establishes current. So I is equals to charge by time period. So it is equals to E by 2 pi by omega. So it is equals to E omega by 2 pi. So the established current due to circular motion of electron in the orbit is equal to E omega by 2 pi. Okay, so when the current when the current is produced there, then it establishes, the current I establishes a magnetic field. So magnetic field around the circular orbit, so that the upper surface acts as a south pole and the lower surface acts as a north pole. Then coming to the area of the orbit, the area of the orbit A. So A is equals to, as it is revolving around the nucleus in circular orbit, so that the area of the orbit A is equals to pi r square. A is equals to pi r square. So then corresponding magnetic moment is given by mu orbital, that is orbital magnetic moment. Orbital magnetic moment is equals to current into area of the orbit. So area. So I into A. So current into area. So that I into A. So we know I is equals to, since I is equals to E omega by 2 pi and A is pi r square, here area of the orbit pi r square. So that substituting E omega by 2 pi into pi r square. So simplifying this, we get E omega r square by 2. So pi gets cancelled. So we get mu orbital is equal to E omega r square by 2. So taken as equation 1. The orbital magnetic moment is pointing from south pole to north pole, that is in the downward direction. So the orbital magnetic moment is showing the downward direction, north. So here south pole to north pole in downward direction. So that the angular momentum of the revolving electron is given by angular momentum is equals to linear momentum into radius. Linear momentum into radius. So we know that linear momentum is equals to m into v and radius is r. So as we know that the momentum mv. So this is the linear momentum. Linear momentum is equals to mv and radius of the electron revolving around the orbit is, that is nucleus to electron. The circular orbital radius is r. So mv or so it is equals to m omega r square. So why we have written here omega r? Because the velocity v is equals to omega r, so that it is equals to m omega r square. So taking as equation 2, then orbital magnetic moment is equals to E omega r square by 2. We know that. Then taking it is equals to E by 2m into m omega r square. E by 2m into m omega r square. So that it is equals to minus E by 2m into orbital angular momentum. So the negative sign indicates that the orbital angular momentum and magnetic moment are in opposite directions. So according to the modern atomic theory, the angular momentum of an electron in the orbit is determined by the orbital quantum number L. So angular momentum of electrons associated with the orbital quantum number L is L into h by 2 pi. L into h by 2 pi. So therefore mu orbital is equals to minus E by 2m into orbital angular momentum. So we know that it is equals to minus of E by 2m orbital angular momentum is LH by 2 pi. So that mu orbital is equal to minus EHL by 4 pi m. So here taking as mu orbital is equals to mu bl. So that is mu b is equals to EH by 4 pi m. So this is mu b. So substituting EH by 4 pi m. So instead of EH by 4 pi m, we have written mu b. So mu orbital is equal to mu bl, where L is 1, 2, 3 and so on. So that when substituting the L values, we'll get mu orbital is equal to minus mu b, minus 2 mu b, minus 3 mu b. So where we have written here EH by 4 pi m, so that mu b is equals to EH by 4 pi m is called the Bohr magneton. So this value is the Bohr magneton, which is called as the fundamental unit of magnetic momentum. So mu b is equals to EH by 4 pi m is the fundamental unit of magnetic moment and is called as a Bohr magneton. This mu b is the fundamental unit of magnetic moment and is called as a Bohr magneton. So this Bohr magneton value mu v is equal to 9.27 into 10 power minus 24 ampere meter square. This is the Bohr magneton value, 9.27 into 10 power minus 24 ampere dash meter square. So this is the magnetic moment which is produced by the orbital motion of the electron. When coming to the spin magnetic moment of electron, so along with the orbital motion of electron, the electron is spinning by its in their own axis, so that spin magnetic moment is producing. So the spinning of electron about its own axis, the magnetic field, and we get it produces magnetic field. So we get magnetic moment which is known as the spin magnetic moment. So that spin magnetic moment mu s is equals to minus 2 into E by 2m into S, where S is the spin angular momentum. S is the spin angular momentum, E is the charge of electron, and V is the mass of the electron. So as we know, spin quantum number, yes, here this spin angular momentum S is equals to sh by 2 pi. So S is equals to spin quantum number, which is the Planck's constant. So spin magnetic moment of electrons from the equation 1 mu s. So from this equation, mu s is equals to minus 2 into E by 2 into yes. So equation 1 is mu s is equals to minus 2 into E by 2 into s. So s is equals to sh by 2 pi. So substituting s is equals to sh by 2 pi, so that mu s is equals to, so substituting s minus 2 into E by 2m into sh by 2 pi. So here s is a spin momentum, spin motion, so that s is equals to plus or minus half, so that mu s is equals to plus or minus EH by 4 by m. So substituting that, mu s is equals to minus 2 E by 2m into s is plus or minus half, so h by 2. So that we get plus or minus EH by 4 by m. So mu s is equals to plus or minus EH by 4 by m. So we'll get two spin values, that is mu s is equals to EH by 4 by m, and also mu s is equals to minus EH by 4 by m. So the Bohr magneton we get EH by 4 by m is nothing but Bohr magneton, so that mu s is equals to plus mu b, and mu s is equals to minus mu b. As we know that Bohr magneton mu b is equals to EH by 4 by m. So substituting, so in the place of EH by 4 by m with Bohr magneton, so mu s is equals to plus mu b, mu s is equals to minus mu b. So the spin magnetic moment of electron is equal to Bohr magneton. So that is Bohr magneton mu b. Okay. So this is about the spin magnetic moment of electrons. Next, coming to the magnetic moment which is arised due to the spin of nucleons, that is nuclear spin or spin of all protons. So magnetic moment due to nuclear spin, mu n. So the magnetic moment of the nucleus is mu n is equals to EH by 4mp. So where this mp is the mass of the proton, So the constant EH by 4 pi mp is called nuclear magneton. The value of nuclear magneton is EH by 4 pi mp is equals to 5 into 10 power minus 27 ampere dash meters. So this is a small compared to the Bohr magneton. So we have seen here the three types of magnetic moments which were raised due to the motion of the particles. That is, so the permanent magnetic moments are raised due to the motion of the particles. That is, so when the electron is in orbital motion, it arises orbital magnetic moment, and because of their when revolving around the orbit, the electron spin its own axis, so that it gives a spin magnetic moment, and then nucleons in the nucleus also spin. So that it gives the magnetic moment because of the nuclear spin. So that three types of magnetic moments are arised due to the motion of the electrons in the orbits and spins. The permanent magnetic moment arises due to three types of motions. So that we have seen that orbital motion of electrons, the spin motion of electrons, and then because of the spin of nucleus. So these three are the magnetic moments, permanent magnetic moments which are arised. So the references for this topic is Engineering Physics by Technology, Tata Material Education Private Limited, and then textbook of Engineering Physics written by M. Alexander and Shir Sagar, which is Chan and Company Publications. Engineering Physics by Dr. M. Arnotha, other publications, and then Engineering Physics by Peter School for which is published by the SciTech. So these are the reference books I've used for this topic. So in the next topic, we shall see about the classification of magnetic materials. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.